third deck below for cargo. Space-wise, it's the equivalent of two complete wide-body cabins, one on top of the other. The new plan called for an aircraft only 2.5 meters longer than Boeing's 747. It was 15 meters wider and 5 meters taller. When they ran the design figures through the computer, they had a shock. The plane was far too heavy.
And we came up with horrid figures, saying, my God, this is the weight of the aircraft, doesn't work. So what we did immediately at the launch of the program, or 2-3 months afterwards, we launched a very strong challenge on the weight.
The team set out to bring the base weight of the aircraft below 277 tons. That's only about 50% heavier than the 747. An ambitious goal for a plane designed to carry over 100 more passengers and their luggage halfway around the world. Unless Champion and his engineers could find the means to beat that target, the dream would die. Airbus engineers were faced with a design challenge that called for a lightweight plane carrying over 550 passengers at a lower cost per seat, not to mention quieter and less polluting than anything in the air. The design team knew they would have to rethink everything. They needed lighter materials, more powerful engines, larger wings, even bigger and smarter factories. Every component would have to be scaled up from supersize to mega size. But even while the engineers were still scratching their heads over the details, the Airbus sales force was already hard at work, seducing customers with visions of the future. They created a full-sized interior mock-up that promised passengers in coach some relief from the grind of travel, with seats an inch wider than in other planes, and overhead bins 10% larger. Each plane can also feature a new interior illumination scheme to eliminate the upsetting effect created when flight attendants suddenly switch on overhead lights. The kinder, gentler system in the A380 mimics the gradual transition from day to night and back to daytime again. These and other innovations make the plane distinctive, but it's the promise of opulent luxury that really turns heads. To help build excitement, computer programmers constructed a virtual showroom where airlines can bring to life their wildest design fantasies.
Ladies and gentlemen, this is your captain speaking. I'd like to welcome you on board this 3D tutorial for the A380 main deck door.
Using this 3D lab in cyberspace, airlines can experiment with cabin layouts, color schemes and seating arrangements. Airbus has encouraged customers to think big. Bathrooms with showers, spacious lounge areas, restaurant bars, and even an in-flight salon. But until the planes are actually put into service, most airlines have chosen to keep their final designs as closely guarded as any other trade secret. But one early enthusiast, Richard Branson, maverick founder of Virgin Atlantic Airlines, couldn't restrain himself. He announced plans for a deluxe version of the A380, featuring a casino and double beds on the upper deck. At a press conference, he famously quipped, "So alongside our casinos, you'll have at least 2 ways to get lucky on our flights." Of course, no dream could take flight until engineers came up with a way to lift all that weight. In late 2000, builders finally settled on a design. For power, they would buy engines built by Rolls-Royce, capable of providing 30% more thrust than the engines used on the 747. Each massive power plant cost $15 million, as much as a ton of gold. Altogether, they account for almost 25% of the cost of the entire plane. But if there's one thing this aircraft needs, it's thrust that won't quit. Each engine provides up to 80,000 pounds of force. Running at top speed, this mega guzzler sucks down a litre of gasoline every second. The A380 is designed for routine flights lasting 13 hours or more. That means when it's fully tanked for takeoff, the A380 carries a lot of fuel. 260,000 litres, 20% more than the load carried by the 747. Airbus has already turned the world into a giant mega factory. With 1,500 suppliers and facilities used to build its existing planes, scattered over 30 countries, yet tightly linked by an advanced communication and transportation network. To assemble the hundreds of A380s the company hopes to sell in the coming decades, planners settled on 5 countries to build the major components. Wings in Wales, engines in England, the fuselage and vertical tail section in Germany, the horizontal tail section in Spain, and of course France, where all the pieces came together to assemble the finished plane. The process begins in Wales, in 2 huge new wing factories, built to assemble the largest and most structurally complex commercial airplane wings ever designed. 32,000 components, shipped in from every continent except Antarctica. The wings on the A380 are true mechanical marvels. They provide flight control and enough lift to carry the fuselage, plus the 4 supercharged engines, each weighing nearly 6.5 tons. And with 260,000 litres of fuel loaded inside 10 interior locations, the wings are also flying fuel tanks. They're one of the most critical structural components in the entire aircraft. The precision construction process begins with sheets of aluminium. Destined to be shaped into the 10 panels that cover each wing, each piece has its own shape and weight requirements. To whip one up, just follow 3 not-so-easy steps. Shade it, wrap it, then bake it. This 34-metre-long slab of aluminium weighs in at 5 tons. Way too heavy for the wing panel it's destined to become. In its final form, it will weigh close to 1 ton. So off it goes, to get the aerospace version of a tummy tuck. Overhead cranes use 32 powerful suction nozzles to lift and transport each aluminium slab. It's a dicey ride across the factory floor before the huge sheet can settle safely into position. Now under the control of a massive horizontal metal shaping device, a milling machine 40 meters long. Like an oversized cheese grater, the precision cutting head slowly cuts back and forth across the surface of the wing, painstakingly shaving the aluminium until the panel shape matches the 3D contour map stored in the machine's computer. The process takes up to 3 days. It eliminates 75% of the panel's weight while maintaining its strength. Then it's ready for the oven, one of the world's largest pressurized heat chambers, 42 meters long, almost 6 meters wide. Technician John Massey has cooked plenty of wings for smaller Airbus planes, like the A320.
It's a challenge to see it go from the size of the 320 to the size of the 380. It's huge, huge jump.